Hi, everybody. In the last video, we saw how to use FTC1 to compute the derivatives of a bunch of functions that are built out of integrals where your variable is in the endpoints of the interval that you're integrating over. So what I thought I would do in this video is give you an example that comes from a midterm that I gave in the fall. And I wanted to give this example because it combines a couple of the different types of things that can happen that we saw in the last video. So here's the problem. We want to calculate the derivative with respect to x of the integral from x squared to 4x of cosine t over t squared plus 4 dt. And the first thing to note is we can't apply FTC1 right away because FTC1 applies to the derivative of an area function which starts at some number, c, and ends at x. So here we have a function of x, not just x, but a function of x in the bottom endpoint and a function of x in the top endpoint. So the first idea is to split this integral into two pieces using one of the properties that we saw in the first video of this lecture. So we know that the integral from x squared to 4x of some function cosine t over t squared plus 4 dt, this is equal to, we can choose to split this up in the middle at any point we want. So I like to always pick 0. So it's the integral from x squared to 0 of this same function, cosine t over t squared plus 4 dt, plus the integral from 0 up to the top endpoint, the rest of the way, 0 to 4x of cosine t over t squared plus 4 dt. And now the idea is that the integral of this function, well, this function is the sum of these two pieces. And we know the derivative of a sum is equal to the sum of the derivatives. So all we have to do is figure out the derivative with respect to x of the first piece plus the derivative with respect to x of the second piece. And I'll do the second piece first because it's a little easier. So d dx, the integral from 0 to 4x of this function, cosine t over t squared plus 4 dt. Notice this function actually is continuous, so we don't have to worry about like putting in a point where the denominator is 0 or something. Everything's fine here. Well, what's tricky about this is that what we have in the top endpoint isn't x, it's 4x. So if we let y equal 4x, we know not d dx of this integral, but d dy of the integral from 0 to y of this function, cosine t over t squared plus 4 dt. Well, this is just equal to this interior function evaluated at y. So this is equal to cosine of y over y squared plus 4. And this is exactly what FTC1 tells us. But if we let y equal 4x, then this is the integral from 0 to y of this function. But remember, taking d dx and d dy is not the same thing. We have to apply the chain rule. So taking d dx of this function is the same thing as taking d dy, but then we have an extra factor of dy dx. So what we get here is what we get by taking d dy, what exactly comes from the fundamental theorem of calculus, cosine of 4x over 4x squared plus 4. But then we need an extra factor of dy dx, y equals 4x. What's the derivative with respect to x? Is just 4. OK. So that's the derivative with respect to x of the second piece. Now let's talk about the first piece. So I'll erase. All right, so we want to figure out what is d dx. Let me just take a minute. Try this. What is d dx? Okay, so our question now is what is d dx of this other piece? The integral from x squared to 0 of this function, cosine t over t squared plus 4 dt. And remember, FTC1 tells us about the derivative of an integral from some real number up to some function of x. So here we have the function of x in the bottom endpoint and the real number in the top. So we're going to use this other property, just like in an example from last time, that the integral from x squared to 0 of any function cosine t over t squared plus 4 dt is equal to the negative of the integral that you get by switching the endpoints. 0 x squared of cosine t over t squared plus 4 dt. So what do we need to know? We now need to know, so what we want is d dx of negative integral 0 x squared cosine t over t squared plus 4 dt, which the derivative of the negative of a function is just the negative of the derivative. So it's negative d dx of this integral from 0 to x squared of cosine t. I want to make sure this still shows up on the screen. T squared plus 4 dt. OK. And what is that? Well, now this is just like what we did down here. If you let y equals x squared, we know d dy of this integral from 0 to y is just this function evaluated at y. And then we have to include an extra factor of dy dx. So what we get is, keeping in mind we have this negative sign here, we get negative cosine x squared over x squared squared plus 4 times 2x. This is our dy dx term. OK, so what have we done in this problem is we started with the derivative of an integral that had a function of x in both the bottom endpoint and the top endpoint. We used this property of integrals from the first video in this lecture to split the integral up into two pieces. We know the derivative of a sum is the sum of the derivatives. And in the first piece, we had to use the chain rule because our top endpoint wasn't just x, it's some function of x. So what happens is you get the same thing you would get from FTC1, just pretending that 4x is y, like putting in 4x where you see a t here, and then you have this extra factor of dy dt. And in the other case, we needed to use one extra property, which was we wanted to switch the endpoints, which picks up a negative sign so that our integral goes from a real number to our function of x. So putting all of this together gives you the derivative of the integral that we started with. And that's it.